Let's take a look at the more recent homework problem. In this one, I just showed you some stuff about the standard functions, the stuff that was built into Python, and then the Python standard library. And I sent you on a wild Google chase to find some information to print something out in its hexadecimal representation, and also to figure out how to get and print the current time. I'm not sure you'll ever use the first one, but the second one's a pretty useful thing to know about. Okay, so I've given you this link in the talk to the functions, and if you go look at this and look through it, or maybe search for hex or hexadecimal on the page, you'll find this routine hex, and calling hex on the number 255, you get back its representation, which is FF. That's what we needed to do for that one. Finding the modules in the Python standard library that handles dates and times, and I gave you a little bit of a hint since I find this thing a little bit confusing. The function is actually named now. So what do? We look up the standard library web page, which is here, and it brings you to date time if you look through it a little bit. And date time contains a number of different data types, and it contains several modules. And when we get to datetime.datetime, which is a little weird to me, but all right, we find function now, and here we go. So we import datetime. We ask for the value of datetime.datetime.now, and we get this. And what do we get? We get a string, which is actually the datetime type. And if we look at it, this is the day, this is the year, this is the month, this is the day. Not very useful way to look at things, but we can display it in a much more useful format by using this str function, which converts it to a string. And to emphasize what I brought out in another part of the lecture about string being different than REPR representation, if we look at these two things, we see the same information, but one case displayed for humans to read, and another case displayed for, well, shall we say programmers to read? Whether that's how that's related to humans, we'll leave for some other talk. So that's how you do that problem. Okay, and then in terms of writing functions, I ask you first to write a function called product that accepts a variable number of arguments and returns the product of those arguments. And then later I ask you to do something a little bit more complicated, where you actually have to think a little bit about how you're going to handle the adjustable number of arguments. First one's pretty easy. I can do it right here in one line. I define product. It takes 4 arguments, but 2 of which are optional. So this will require a minimum of 2 arguments, but it'll accept a maximum of 4. And I've set the default values for the 3rd and 4th argument to be 1. Okay? And then I just simply multiply them. So if you call this with 2 arguments, you get its product. If you call it with 3 arguments, you get its product. If you call it with 4 arguments, you get the product, because it just substitutes 1 for anything I didn't specify. Not hard. Okay. Second one is a little bit more tricky because I'm asking for both the product and the sum. And now I can't depend on a default value of 1. So how do I handle that? Well, there are lots of ways to handle it, but probably the best one is to use this tricky Python value of none. Okay? Why? Because I can't do anything with none. I'll just test with it. So now I write it with the default values of none. First thing I'll do is I'll compute my sum and product of what I have to have there. Then I look at what's next. Now you could say A3 equals none, or actually not equals none. That would work fine. It might not work fine in a few versions of Python. It works fine in what's called CPython. I remember somewhere seeing that this isn't a good thing to do in Jython, which is the Java-based Python. But as far as I'm concerned, that's a bug. But this is the correct style to use as far as it is in terms of the recommendation. So if A3 is not none or not equals none, then increment the sum and multiply the product, and then do the same thing for A4, and then return those things. And now I get exactly what I had before, but now I return a tuple that contains a list and containing the sum and the product. So a little more complicated than the previous example, but it gives you a much better feeling for how to use variable numbers of parameters in a more sophisticated way. Okay, so that's it for the homework.